Before we go into property-based testing, or testing in general, let's walk over our example. We have a form in our browser that is expecting our last name. I put a little bit of debug information at the bottom and I'm printing out the status of the form. So if I type in my last name, hit submit, we see here the values of the form, we see there's no errors, we see that it was touched, and we see that it was submitted. If instead I put some numbers, I click submit, an error comes up, and you can see in the state of that form the value that I was set, the errors that were detected, and the form is touched or dirty, and then that the form has actually been submitted. So let's walk over the code just really quickly. We're not using any other library other than React.js, but this is applicable to any library out there. But in our case, I want to mention that specifically because usually people tend to use something like Formic or another library on top of React in order to process the forms. So in this case, we're not gonna do any of that, but we do have a little bit of code to mimic what Formic and its validation companion, Yup, would actually help us with on a form. So my index, pretty clean, just including the root and including the app. So nothing to see here. As I go into the form, here's what we'll see. Here I have an object that includes some validations. So this is where it started to look like Yup and Formic. Yup being able to define your validations. So I have a list of validations here. So if we go into that file, we will see a complex validation, or let's call it complex because it's for me, anything that has a regular expression becomes complex because I'm really bad about reading and understanding that. I always forget how to read them and how to form them. I always need to go to the browser and an online tool to format. I'm really bad about it. So for me, this is a complex set of functionality that if I have to test it or if I have to explain what is going on, it's hard. I know, I can read this very well, but then as I start looking at more symbols, I'm like, why would somebody do this? Why? I need a unit test to read what actually being covered. I need a comment. So if you ever receive this as somebody that provides you a story, and this is the pattern that you need to apply, it's beautiful because they're giving you something out of the box, but at the same time, it's not so easy to understand. And so this is the basis of what we're going to use as an example. So you can see here that then depending on how the test happens, we say that it's an invalid last name, and we apply something a little bit more simple, that if it's less than 3 characters, okay? So you see we have an invalid last name, and this is because it's a number. If we put 2 letters, you see we get the last name needs to be at least 3 characters. So we have these 2 validations, a regular expression and just the length of the input, okay? So going back to our form, doesn't really matter how we accomplish that. I think the most important part is the validation, because that's where the logic, the most complexity happens. So we can see here we're handling the form using the useState hooks and changing the state. We have the values and we have the touched, just to track a little bit the state of that form, and then finally if it's submitted or not. So we do our handlers, and here when we submit the form, this is where we basically apply the form validation, right? And then we just record or set the state for the errors and for the touched. So nothing important. This is not really relevant, more than just trying to reproduce a little bit how Formic would do it. In case you're not familiar with it. So Formic, it's a beautiful library created by, I hope I'm not going to butcher his name, Jared Palmer. Pretty smart guy. And so here, depending on that validation, a comparison of whether there's errors and it's touched, and so forth, we define whether it's a valid state and whether it should be submitted the form or not. Okay, and this is just our form. We have an input, where we attach all the handlers and indicate that it's required. and then we show our errors, and then our submit button, and then I have a little debug component that is just displaying this value, not much more than that. If you're working on a project and you have an agile process around it, you're gonna get a story that has user requirements. Again, maybe there was some tech grooming and you got even the regular expression, or maybe you just got a list of accepted criteria, of acceptance criteria. Something like, oh, it shouldn't be less than 3 characters, there couldn't be any special characters, and it has to be a string and these kind of things. If not, I mean, you can start working through this and then you realize, okay, yeah, so it's a last name, so what could be? It's like, okay, so, and you start defining your own criteria. And one of the things that you would do is you start playing with this and you say, okay, so my last name, okay, that works just fine. If I put some numbers, it doesn't. What happens if I combine both things? it's still invalid. And so the other thing is you start thinking about last names, right? So you start thinking about what is the minimum size length of that last name could be. And then you start thinking, is there a max? And then you start thinking maybe, you know, oh, I have a friend that actually, his name is like this. So he has like a special character. And so, okay, so that works. That's good. So you start playing with different things. But what happens if, you know, we start doing something else? So kind of like put in some other special characters. Okay, so that passed. Is that okay or not? So you start playing with all these different permutations or ideas, trying to capture as much different variations or scenarios as you can think of, right? But that's a little bit the problem. Now we're limited to the person who's writing the code or the person who writes the acceptance criteria or the combination of both. So yeah, so that's where we're going with this. So let's see how we do that. So we're gonna go for write an integration test and a unit test. When we're talking about integration tests, we're going to test kind of like the whole system. In this case, it's a single page that has all the components, no mocking whatsoever. So that's going to be our system. That's the overall, the entire thing that we have today. It's the entire application. It's just this single page with a form, with an input, with all its validations. And then we're going to go also for the validations logic, and we're going to write a unit test for that. So let's go with that. Let's take a look at the test. And before we do that, we can talk a little bit about what tools we're using. Again, it's not that matters that much, but for reference, it will be interesting. So we're using the testing library, and we're using the React adapter for the testing library. The reason I really like this is because it focuses on the user behavior and not the implementation details. It pushes you, it forces you to have the discipline to not get into the implementation details in order to grab the elements and the things that you need on the web application. So let's do that. So let's open here the integration test. And so as you see, I already wrote the test for us, some of them, right? So based on the rules that we had, and let's open that, right, in a different part. So let's close that, and oops, where's my test? Okay, let's do that again. Okay, so we're gonna minimize our application, and we're gonna see, okay, so let's start with a simple one. Okay, it has to be at least 3 characters. Okay, so should submit his last name when passing more than 3 characters. I think it should be more than 2. So here I have the logic where I basically, let me show you, I render the form, and then I get a hold of the last name input value. I actually changed that to be my last name. So this should be passing at least 3 characters. Okay. And so basically then I trigger the blur, kind of like simulating what the user would do, and then click on submit, and then I expect the error not to be there and the state to be submitted. Okay, so that's pretty good. Okay, so I'm trying to represent this rule over here. make sure that I'm validating that that is how it behaves. And then I'm thinking, okay, so we talked about the example about having the special characters. So now I can combine both. Some of the regular expression means that it accepts the special characters. So what I'm trying to do here, some of the ones that are accepted. So I'm gonna say, okay, so kind of like same deal, but now I pass a name that has the special character. And then I, validate more or less the same. So again, this is good. Maybe I'm not covering all possible special characters, but I'm providing one example. Okay. And then I'm saying, okay, what happens if it's empty, right? And we can actually test it. So let's refresh it. Oh, I didn't have it running. So let's do that. So let's keep both things running. We're going to run the tests and this. But in the meantime, let's make sure the test and everything is running. So if I submit, yep, so the required attribute from HTML triggers seen, right? But let's see what our test says. So it should display an error when last name is empty. So let's see. Okay, so it's not really the one that we're expecting. So if I pass an empty character, that is the error that I'm seeing. If I don't, then the HTML auto validation triggers seen because I have not disabled that. But if I pass an empty string, then it is the last name is required message that we expect. So here I pass an empty value, and again I pass an example of the input, and then I provide the output example that I'm expecting. So far so good. It seems that we're covering more than a little bit more of the validation. And then as I go down, so let's check a little bit the negative cases. So if it's less than 3 characters, I expect to see the error again, kind of like with the empty one. So I pass in 2 values and I expect the error. And then eventually I expect that if it contains any numbers, then, something like this, then I get the invalid last name. So far so good. Now the key here is that what we're doing, and we don't usually refer to this as such, but this is an example-based testing, and this could be unit or integration test. It doesn't really matter. You basically provide a variation of the input, and you assert for a certain expectation, right? So in this case, with just a little few lines, right, we have this regular expression and just this conditional. So basically 2 lines where we are applying logic generate 5 cases, 5 variations, and it's not nearly the entire amount of different variations that we can do, but it's represented enough. And this is what I would do maybe a few years ago when I had to represent a test like this. Maybe I could add a few more changes or to represent more than just one special character, but overall, it would seem like if I put a pull request out there for this, it would seem more than enough for some people. Maybe some will recommend doing a few more, but I think most of the times, 80% of the time, this will pass. And it will be noted as a certainly good coverage. But as I was going through each one of the examples, you might have noticed the amount of repetition that we have. So as I go here, kind of provide the same setup, right? I render, then I find the input, I generate the change, then I blur, then I click, and then I expect something. And if you go through each one of these, they're more or less the same, right? So let's pick any of this, and you can see exactly the same structure. So this is where people get smart, right? This is where either you get the recommendation or you are at that level where you say, oh, no, I can do this better. And so people would have a couple of options. They would actually create a function up here to kind of like do the whole thing. And then so you basically in each here, you pass a function with, you execute a function with you passing certain values, even the input and the expectations, and then you can create that on the run. So that's one option. Other people would say, well, actually, there's no need for us to create such thing, because in this case, Jest, but other libraries do the same thing, kind of gives us that. Okay, so we'll go over that. So before we do that, let's go ahead and run our tests. As you can see, I'm only executing those 5 over there. Well, we may have more in other files, but in here we're only executing those. So if I do form.spec, right, so those 5 tests passed, okay, and we're getting everything. The other ones that we have in the file are being ignored on purpose because that's the next step. Okay, so we have those. I'm gonna actually ignore this 5 that we created and go for the next version of this, right? And the code is already written out, so you don't have to see me writing the code. And I'm gonna go for the next one, which is kind of like the next version. It's Let's Get Smart version, right? Where I know that I have different variations and I have different expectations. So I leverage something that it's available in Jest that allows me to iterate over certain inputs and expectations. And then I can just use them in a single function. And it can be a dynamic test. So I can say, should submit last name when last name is whatever. This takes the first value. Error is, and whatever is the second value in the array. And submit state is whatever, and it's the third state. So basically I create this only once. I render the form. This is gonna be executed multiple times, but I write the code only once. I get the value, I generate the change, blur, click, and then basically on the error, I have some expectation, whatever that is. You can see here last name, error, and submit status coming from each of these arrays. And then I do the same thing for the submitted status. So as I run this, I'm gonna go through exactly the same 5 scenarios that I had before. Let's do that. And it will go exactly through each one of the validations. I have 5 tests that passed. So we are really smart now. Okay, single test, 5 validations. Now if I wanted to add more validations, we can add them over here on the top. I don't have to write more. So this is great. And it is. And you can see more than ever that this is an example-based testing. So kudos to us. We are smart. I would say efficient. Maybe not. Well, I would say efficient and biased. I think it is smart. But this is a biased example or example testing, because what we're doing here is we're basically doing the same that the acceptance criteria or our coding dictate, right? So to the best of our knowledge, we're following exactly what we need to accomplish, and we're writing a test that conforms to that. And even if you were following TDD, this will kind of reach, you will reach kind of like the same point, because you know what needs to be done. So you're a little bit biased towards that. And, you know, if this is why it becomes sometimes obvious when you have a QA engineer in the team that they think through corner cases that we have not as developers think through. And this is where the different mindsets are pretty obvious sometimes. Not to say that developers cannot do it. It's just that most of the times developers are very biased towards fulfilling the requirements. So it's sometimes hard to see the negative cases or the very crazy variations that we think, you know, a user might not actually follow. So far so good, but I don't know if we're covering all possible scenarios. I'm covering all the ones that I can think of, but not all of them. So I'm gonna ignore those, and I'm gonna walk you through property-based testing now. So property-based testing is a little bit different on how the setup works, or how you follow that you know, lead or on what you need to test. So the basis of that, the basis of property-based testing is you're trying to define, you're trying to validate or define a model that represents your system. And so far it kind of feels the same as when you're trying to explain TDD, where you're trying to write the test that reflects the rules or what are the truths of your system. But the difference will be that we're not going to detect the examples. We're not going to provide examples to the test. We're going to define the model, and we're going to define through the model the type of entity of value that we're going to input and output. So if we look over here on our array, we do have a specific types that we want to follow. So let's go a little bit through the example because I think that would be easier. So here we're going to use the fast check library in order to do our property-based example, and obviously there are many and obviously there are different ones depending on the language that you're working with. So here it explains how, fast check in particular in our JavaScript world, it's inspired on or comes from the functional world, or property-based testing is actually, and so introduced by Quick Check in Haskell, and it's just a different approach to your test to validate your functionality, right? So the idea is that you have properties on your system, right? So these rules, these truths that are valid on your system. And so it's basically defining those rules and let the library, in this case, go through many possibilities. Let's leave it at that right now. So let's see an example. For any strings A, B, and C, B is a substring of A plus B plus C. Okay, so kind of like we're defining our acceptance criteria again, but we're trying to do it. Well, some acceptance criteria can be really generic, so this is kind of like following the same thing, but we're talking about how to define this in the test. So let's take a look at an example in our code base. So the first thing that you will notice is that, to start with, the internals of it, about the execution, it's no different. We have exactly the same thing as we did in our smart test. We have a form that renders, we get the label, we provide the change event for changing the value, generate the blur event, the click, and then, we have the error and the submitted. And in this case, it's a very generic way. We're saying every time that it has to be the context. So this is kind of like the positive scenario. So if we pay attention, the internals of our test are the same as we had in our smart test. So we have a render form, we get the input, change the value of that input, generate the blur event, then we generate the click, and then we make sure there is no error and the submitted status is there. The reason why is we're gonna actually cover first the positive scenario. We're gonna go through the error next. But if you pay attention, the only difference is how we provide the input. You see here, when I provide the change value, I'm picking it up from the arguments of the function. And here's how we define that. Okay, so we are using one of the out-of-the-box arbitraries, kind of like types or entities types that we can have. They're a little more than just a type. It's not just saying string. There's some constraints and definitions to that. And they're referred as arbitraries inside the fast-check property-based testing library. So here we're saying it's a string and it has a minimum length of 3 characters. All right. So, and that's about it. So what kind of example is being provided inside the test? It's actually provided by the library. So let's take a look at that really quickly. The library shows that there are some built-in arbitraries and then you can define your own. But let's go for the built-in ones. So let me increase a little bit the size. So you see here we have Boolean, numeric, string, date, an array, and some combinations and others. So I'm gonna go for string. And you see here you have good amount of examples. Right, so either from a single character to multiple characters, and then this is the one that we're using right now, and so it has a minimum length, and it even has a max length. And so you can see here some of the examples, and not only that, you can see some of the examples that will be generated through this. You see it's a string, so it can definitely have some special characters. All right, so that's where we were going for that, right? Remember that we do accept the special characters. And so we do have a minimum length, but we didn't define any max length. The beauty of this library is that it has a lot of examples. So you can even have JSONs, and even, let me see, where are those? Let me look. Okay, there you go. Okay, we can even have some using the templating lorem ipsum kind of like set of words and paragraphs. So we can define that. We can define how many words, how many sentences. So you can create some examples through that. Then we have some basically domains. Let's see what else we have here. Okay, so let's see web authority values. Let me see if we can find something more representative or more common. So email address, for example. Okay, you will have a little bit more than most probably you would have thought of, including special characters and whatnot. We have the URLs. We have dates. So as you can see here, we have a good amount of different example generators. I think that's kind of like you would refer to. And you will get it out of the box, basically. And so let's stop there just for a minute. So basically what we're saying is that there is a function that iterates, okay? And then it even inside that, it knows how to auto-generate some examples. So, remember that we said before we go into the smart about, leveraging Jest to iterate for us, we said that one of the options was to generate our own iterator and, just pass in the examples, the inputs and the outputs. So what prevents us to, go in one more step and have a function that generates multiple examples? There's nothing prevent us from doing that. You can do it. Okay, but you're writing more code, and then are you covering all possible scenarios? How smart are your generators of the examples, right? So if you want to think about property-based testing or FastCheck as just a convenience library that helps you accomplish that for free without spending time or money, think about it that way. Keep it simple, narrow it down to the smallest expression, which is, well, it basically iterates and generates a lot of examples. So if that's what it is to you, it's beautiful, right? It will help you, and we'll see the example right now, to avoid being biased or limited by your own imagination, which in my case is minimum. Okay, so I'm always trying to find tools that help me accomplish something in a much efficient way or in a way that I cannot think through. So we have this, and so we're gonna remove the restriction to this. Okay, and let's see. Now take a look at this. My test has failed. And so this is the beauty of it. If there is a valid reason, we're about to discover, if there is a valid reason for my test to have failed, that would mean that among the strings with 3 characters, there is one variation that I have not thought of in my test so far, that it's actually a valid one based on my model, right? There's a valid scenario that I have not thought of, and it actually fails. It doesn't do what I expect. It doesn't get to the submitted state. So let's see what that is, okay? So as I scroll up, we're gonna start seeing what happened. First of all, the status is pending instead of being submitted. So that's really not what we expected. So let's see what happened. So we see here one of the possible scenarios. Okay, and this is how you read it. This is the ID that represents the run. Why am I saying the run or the iteration? Because what this tool will do is they will run through many different variations. How many? It will depend on the model, on the complexity on the model. It will try to satisfy as many variations to make it significant, statistically significant. So it actually proves that, you know, it actually works. So the first time you run, it will run through many variations depending on the complexity of your model. And then the second time I even run through less than that until it is actually satisfied that it has gone through everything. So, but you can at any point provide the specific ID to your test and it will run every time the same variation. What is that variation in this case? Well, so this is the example. So it looks like we have one scenario here that we haven't thought of. So we see here that there is an empty character plus 2 characters that actually has a value. So basically a space. And this is true. There's some names that have a space, an empty space, an empty character in between. So if we go back to our example, let's refresh that. You know, we know that without spaces it works. But what if we have, we mentioned this, right? We mentioned this with the special character in between. That works. But what if we have like this? Oh, so we got an invalid last name where we have a last name with an empty character in between. Granted, you could have thought this and you could have written a test for this, but I did not. And so this is actually discovered by this test. And the point being is that when you're going through different things and you're creating these models, you may encounter that obviously the generator library covers many more variations than you do. And it goes through hundreds of different examples. So sometimes you think about things, but you don't want to write 1,000 tests. So this tool, if you even think about all the different possibilities, it will run through them or enough to make it statistically significant. So that's the beauty. Even if you can think about all the variations, you don't have to write all the variations. So again, if you want to keep it at a minimum expression, it's still a useful tool. Not that you're going to go about changing all your tests to make it property-based testing. There's no such thing. Unit test does not, you know, cover the integration tests. Integration tests do not cover the end-to-end tests. End-to-end tests do not cover X and Y and Z. There's an overlap in all of these things. It always is. And always the challenge is to find the right balance between them. So let's take a look. Here, I actually did a console log and you can see how we went through different things. And so it went through actually 5 iterations before thinking that it was covering enough ground. So you see here, this one was valid, this one was valid. And you can see we're using small caps and not, which is another example that we didn't think of, but it looks like it's being covered. So that's something that we haven't thought. So that's another one. And then it actually found an issue right away. Okay, so if we were to cover this, most probably we'll run it again and maybe we'll find a different scenario. So I'm going to stop right there. Okay, and this is what we can do with property-based testing. Without adding much more code, this is a very simple scenario that already catches one of the issues. But this is done at the integration level, right? Because it doesn't really matter if it's integration or not. So I want to show you a different one. Okay, we talk about, this is kind of covering the whole system. So I'm going to actually go over the specifics of our validations. So this is our validation function. Takes 2 inputs and then basically generates something out of the box. It returns an object that has the name validation. So we can actually play the same exercise over here. So if I do your test, and then I only gonna look for this test, you can see we have 5 tests that passed. And these are kind of like the similars that we had before, but we're applying this to a specific function. Should return no error when passing, again, not more than, but at least 3 characters. And so we have an input. We expect, you know, the output to be null, no errors basically. And so we execute the function and then we compare the output with the input, and it should be what we expect. Same thing for the special character, same thing for an empty string. Then we expect an error when we pass less than 3 characters. Here's the expectation. And then we generate another one for invalid last name. So we exactly the same scenarios. And so as you might already guess, it doesn't make any difference. If we try to make it smart, either we iterate over strings or we leverage xstate, my God. We leverage the jest iteration, and then we get smart. We provide an array of examples and expectations, and we write it only once. So then people might diverge into creating their own example generator, and that's where I think you start making a mistake, because now you're getting into what other people took a really long time to create, and you're not leveraging that. But you can certainly do it, and then, you know, single function and then single function to generate all these different arrays, and you get a lot of variations. But still, a lot of variations are going to be maybe not all of the variations. So you can get smart, but again, it's not about being the smartest, it's about a lot of people being smart altogether. And with time, you generate something much more elaborated and solid than what you can do in a single day in just a couple of hours. And so finally, we get to our property-based testing model, and you can see here that we have a single case where, again, same code, we execute the function based on a dynamic value that is generated by our property arbitraries, which is exactly the same, and then you just expect that to be null. So if we run that, obviously it failed as we had expected. Okay, and here we can see that, let's see, our example again has the empty space in the input, right? This is exactly the same thing that we found on the other level. And we see here a seed. So this is what I want to show you. So I registered the same one example that I got before, and I specified the seed, but we can actually use the one that we just got. This is how you would reproduce a specific scenario if you want to pursue that. So, okay, I need to be a little bit faster than that. So you can actually stop and write this, but we have the 2 zeros. This is kind of like the paths, how many levels. So we're gonna change that, do this, and write that. And so we should be getting always the same example. Again, always with an empty space. So if I run it again, we should expect to see exactly the same value. I didn't enable this, so that's why you did not. So you can pass to the assert, you can pass an options function that has these 3 values. And so now we should always see the same one. Let's see if that is true. Run it again. Yeah, we see always the same example being executed. So if you're stuck on one and you want to see that one specifically being executed again and concentrate on that one, because maybe you have multiple reasons for that to fail, you can always provide your own seed or the one that you want to attack or work on, the path, and you can say verbose to get more details about it. But that's how you would go about it. Okay. So we're commenting this out so it goes through all the different possible scenarios, and you can see how it always gets this other scenario that we didn't think of, that we haven't thought of. So to sum up, property-based testing is just a tool. To the minimum expression, it's a tool that allows you to think in a different way if you want to, if you assume that challenge to think in rules and truth of your system. And again, if you go through the documentation, you will see that the spirit is to write even these expectations or descriptions in a different way, following a little bit more about rules of the system. To the minimum expression, you can write the same way that you write them before, but you can use it to generate a lot of variations. And on top of that, it also gives you the possibility to run through a lot of iterations, not just the generation of the variations, but it gives you a way to run through all of these things all together. Kind of like just, if you're using that, gives you to iterate over all the examples. But now we're shifting from example-based to property-based. So we're defining the model and not explicitly defining the examples, which again, we're going to be biased for, and we're going to be limited in our imagination, at least compared to what many other people already put together, as you can see here. But sometimes this is not enough, and you can create your custom ones. So there's a lot of stuff that you can do about creating more complex versions of the models. So I'm not going to go into that. This is just to the minimum expression, how to leverage a tool to be efficient when you write a single test but cover many scenarios, and to cover all possible scenarios for the right type and not just the ones that you can think of. So a tool to leverage to cover more things at once with a minimum amount of effort. Other than that, you can take a look at this fantastic library. I would say that at the beginning it takes a little bit of time to kind of like adopt the mindset, unless you're already working a lot in functional programming. I think that would be much easier. But if not, it takes just one click or two to come to the realization of what you're doing. Other than that, and we're not gonna go about it on this video, this library gives you more things than this. They have other ways to actually test that I am really passionate about, which are more about, instead of property-based testing, about model-based testing, which sounds the same, but it's not. But I'm not gonna go over that with this. If you're coming from Go, if you're coming from Java, if you're coming from any other language, there's a version of this. So if we go to Go, property-based testing, the library that it's out of the box in Golang actually has the ability to do this, because, well, I think Gopter is one of the ones that are mostly adopted, but I think the one that comes out of the box, it's inspired on Haskell, on Quick Check, so it already has some of the abilities that you can do exactly the same thing. You can use it for that or not. So every language has its own good way of doing this. So yeah, so this is about it. I hope you enjoyed, and I hope you don't become a fanatic, that you just get a new tool and apply it appropriately. Thank you.